Hello and welcome back to this mini-series where we'll be discussing RStudio's package ggplot 2 and all the different ways you can visualize data with it. In this video, we'll be discussing bar graphs, line graphs, and scatter plots. If you haven't yet watched my previous video, I suggest you do, as a lot of the topics I'll be discussing in this video build off of themes discussed in the last video. With that being said, let's dive in. I'd like to start this video off by working with bar graphs, but before I do, I'll have to introduce data framing. When creating graphs in ggplot, you'll need to give it a data source to pull from. In the first video, I just used the mini ANES dataset as a whole, but you can also create a custom data frame to pull from, and that's what we're going to use in this video. The reason we're going to use data framing for this is because creating bar charts, line graphs, and scatter plots requires a little bit more math, and ggplot can't do that all on its own. To give an example as to why this will be so helpful for us, in the last video, we were only able to work with summary statistics. ggplot was only able to pull distributions of data, and we can only introduce a second variable with subsetting. By creating our own data frame, however, we won't just be able to introduce a third variable, but work with things like means and standard errors. Having that flexibility will allow us to create more complex and interesting plots, which is what I want to discuss here today. With that introduction out of the way, let's jump on in and start creating our own data frame. Continuing from the last video, we're going to keep our feeling thermometer of scientist measure and our PID measure. Additionally, we're going to keep our recode factor command so that PID3 is no longer numeric. The code I have here is telling R that we want to find the mean of a certain variable based on another variable, and in this case, it's our FT scientist measure based on our PID3 measure. Additionally, this last argument is telling R that we don't want to include NA responses. When we run this code, R is just going to spit out some raw numbers, but these are what we're going to use inside of our data frame. What this tells us is that the mean opinion rating of scientists for Democrats is 87, for independents 79, and for Republicans 70. This shouldn't be at all surprising, given that the density distributions we made in the last video reflect these well. We can start to build our data frame now, but in order to do so, we'll need to first create some vectors. You can think about these vectors as columns in our data set, and they'll look a little something like this. What we're telling R to do is to create two separate columns titled with our variable names. So our first one is our PID measure, and it'll go Democrat, Independent, and Republican. And our second one, Scientist Feeling Thermometer, will echo those with 87, 79, and 70 respectively. This ensures that when the frame is created, our values match up. We're all ready to create our data frame now, and we'll do so in a similar fashion to how we created these vectors. First, we'll give it a title. I'll call mine sci.df for scientist data frame. Use an arrow, and then use the command data.frame. Then we'll open up a bracket and just list the names of our vectors. So for this one, we'll use PID and sci.ft. We can run this, and then to see what this looks like, we just run sci.df. And here's our completed data frame. We can start to create graphs now, and just like the last video, we'll start basic and build our way up. Like always, we'll start with the ggplot command, but then for our data name, we're not going to use MANES, and we're going to use our sci.df data frame we just created. Throw in a comma, and then we can start our aesthetics tab. And here's where we'll tell R what variables we want to use. We have to be careful here, because unless a variable is specifically included in our data frame, we won't be able to use it. So our choices here are PID and sci.ft. For now, let's stick with PID on the x-axis and sci.ft on the y. Then, we'll use a plus sign to come down to a new line and start our geom argument. And for this, we'll use geom.call. We'll add a bracket to our geom argument, and then we can run it. And here we can see our basic bar chart. Because we're looking at the same example as last video, we can reuse a lot of our aesthetics. For example, we can keep our labs command and our scale fill manual, along with our theme. The only thing we have to add is our fill argument. And we'll set that again to PID. This is pretty easily going to give us a really nice looking graph. As you can see, things are broken up by party with the correct colors, and they're showing the average mean pretty well. However, there are a couple things I want to tweak. The first thing I want to change is make it so that the means are better represented in this graph. I think this does a pretty good job of overall showing what the trend is, but because we're working with means here, and the scale is a little limited, I want the exact numbers on this plot. In order to do so, we're actually going to use a second geom argument, this one being geom text. Like our main ggplot argument, we're going to use aesthetics, but we're not just going to use x and y here. We're going to use an argument called label. Because we want these labels to show the means, we're going to set label equal to sci_ft. Again, adding a plus sign to connect it to the rest of our code, and when we run it, we'll see that our means are represented on their plots. While it's nice to now have these numbers in here, we still have to do a few things to affect their readability. We're going to stay working in our geom text line, and I'll introduce an argument called vjust, which affects the vertical adjustment of an element. In this case, we want this to go down a little bit, so it's sitting inside of our bar, so we'll set vjust to a positive number. For now, I'm going to use 1.5. Additionally, I'm going to change the color, and like usual, I'll set it to white. When we run this, we'll not only see that our numbers have shifted down, but the white color makes them a lot more readable on their colored backgrounds. This graph turned out great, and I think it's time to move on to something a little bit more complex. I mentioned before being able to use more than just two variables, and I think now is the time to introduce that concept. At risk of being a little bit overwhelming, I'm going to introduce a lot of code at once, but I'll explain it step by step. In order to effectively use three variables, we're going to have to do some subsetting, which is what I have here. I have my subsets set into three groups, one for each party, so I have 3 for Democrats, 3 for Independents, and 3 for Republicans. What differentiates them is the value on the education variable, which I've introduced here. The mini ANES dataset I'm working with has this education variable scaled 1 to 5 from no high school education to postgrad. I've chosen 2, 4, and 5 as they represent having a high school education, having a college education, and having a postgraduate education. When turned into subsets, this means we have 3 groups of 3, where each party has 3 measures for a high school education, a college education, and a postgraduate education. You can think of these subsets a little bit like the data frames we made before, as when we start to make our means and standard errors, we won't be using the mini ANES data, we'll be using our subsets. After running our subset commands, our next steps are going to be pretty similar to how we created a data frame before. We'll use these next 2 blocks of code to tell R to do the math that ggplot can't do on its own. Like before, we'll be creating means, but for each of the subsets. Additionally, we'll be creating standard errors as well, which will come into effect later. All that's left now is to run the code, but before you run the standard errors, make sure you have the plotworks package installed, otherwise these won't work. Once you have all your raw numbers, we'll be creating a data frame similar to how we did before. We're working with 3 groups of 3 here, so each argument should have 9 total points in it. Additionally, just remember to have everything lined up. It might be easier to think about this with columns, where each subset has its own column. For example, the first subset, Dem1, would be this column, where you have Democrats with a high school education, and this is their mean feeling thermometer of scientists, and their standard error. We can check if this matches up by going back to our numbers. We see that, for Dem1, their mean feeling thermometer is 84.4, and their mean standard error is 1.01. After we run all of our commands to get our vectors, we'll make our data frame just how we did before. We'll give it a name. I'll call this one sci.df2, and use an arrow into our data frame command. Open a bracket, and then all we need to do is list our vectors. We'll start with PID2, and then education x, then sci_ft2, and then sci_ft.se. After that, we can just call the command by its name, and we can double check to make sure it looks right. This looks awesome, and after checking the numbers, everything seems to look right. We have our feeling thermometers and standard errors, along with our 2 variables. We have everything we need to start graphing now, and as you might expect, we'll be reusing some code here. We'll switch a few things around, like changing our data to sci_df2, and changing the fill argument to education x. This is because we want 3 groups of 3, so we want PID on the x-axis, but grouped by education. While it looks a little strange, ggplot did what we told it to do. We have 3 groups of 3 all on the x-axis. All we need to do now is introduce a couple new arguments in order to have them sit next to each other, and we'll color code again. First, in order to have the bars sit next to each other and not on top, we'll use the argument position equals dodge. While we got the bars to sit next to each other, this actually caused another problem. Unless you tell it otherwise, R will sort things in alphabetical order, and in this case, college starts with a C, and that goes before high school and postgrad. In order to fix this, we're going to use a modified version of our factor command from earlier, and it's going to look a little something like this. We're going to tell R that for our education x variable within the sci_df2 data frame, we want it to be sorted from high school to college to postgrad. This will help the order of the graph, as we want things to go from the lowest education level to the highest. Additionally, after we run this, we have to remember to rerun our dataframe command, because this is editing the dataframe. When you run commands like this, R won't automatically change your initial dataframe, so you have to remember to go back and do it yourself. Now that we have our edited education variable, we can rerun our ggplot command. This is looking a lot better, as the bars are not only sorted by party, but also by education level. Similar to how we added the means to the bars in our last plot, we'll be using another geom argument. This one, though, is called geom error bar. What this does is tell R to create little error bars on each bar based on certain values that we input. And in this case, it's our means and our standard errors. The minimum value will be our mean minus 2 standard deviations away multiplied by our standard error, and the max will be our mean plus 2 standard deviations times our standard error. If you're familiar with standard deviation curves, you'll know that 2 to each side makes up roughly 95% of the distribution, which is what we're looking for. What we're showing when we add these to the graph is that we're 95% confident the actual mean falls in between that error bar estimate. This is super useful if we have a lot of plots like this, because overlapping numbers can become pretty common. We can now run our edited ggplot command and take a look at the error bars we've made. Obviously, something is pretty wrong here, as everything is not only centered on the main bar, but super wide and completely unintelligible. To fix this, we use a couple arguments to not only have each error bar centered on their graph, but small enough to where they're not too intrusive. Working within our error bar command, we're going to use a position argument here. However, we're going to set position equal to position dodge. And then open a bracket and set that equal to 0.9. Again, this is another one that you can play around with a bit to see what works for your graph. Lastly, we're going to change the width of our bars. And like other size commands, width is centered on 1, so we're going to do something smaller like 0.5. When we run this, we'll see that our error bars have shifted, and they look a lot nicer now. The only things left to do before I'm ready to call this graph done are to mess with the aesthetics a bit. Like usual, I'm going to change the axes names and the title. I have some pre-made titles, and I'll insert those now. I'll change the x-axis to partisanship, the y to mean feeling thermometer, the title to scientist feeling thermometer by party and education, and I'll get rid of the legend title. We already have our fill argument up here as well, so it makes sense to use scale fill manual to give ourselves some custom colors. We'll set values equal to C, and then we'll insert our colors. I think a green gradient might look nice, so I'm going to use something like this. We can again just add a plus sign to connect it, and then we're ready to run it. I think visually, this graph looks fantastic, and it also communicates really well what I'm trying to get across. We can learn some really cool things just because of how this graph is set up. We can see things like the largest opinion gap is between independents who graduated high school and graduated college, and that Republicans across the board have pretty similar opinions. I think my favorite part about this graph is actually the error bars. Not only are they showing each bar's individual confidence interval, they're showing which bars are the strongest. We can see that Democrats with a postgraduate education had a very tight error bar, which means that their distribution is also pretty tight. What this tells us is that there's more uniformity in this population than there are in others. I'm happy to call this graph done, and this wraps up the portion on bar graphs. Up next, we'll be discussing scatter plots. Transitioning over to scatter plots means we're going to have to switch up our example a little bit. Scatter plots really like to use 2 continuous variables, and while the dataset I'm using doesn't have any, our 1 to 100 feeling thermometers will do a good job in replacement. For this example, we're going to keep our feeling thermometer of scientists measure, but on our y-axis I'm going to introduce a pretty interesting variable, a feeling thermometer of Christian fundamentalists. Our geom command for this is going to be geom point, and then we're ready to run it. This basic graph that we have already shows us some cool stuff, like these crazy outliers where people voted 100 out of 100 on one category and 0 out of 100 on another. Additionally, we can start to see a distribution forming, with a lot of the overall points being above 50 on the FT Scientist scale. This graph can pretty clearly be improved upon though, so let's start making some changes. First, we're going to add the aesthetics commands that we always do, our labs argument and our theme argument. Next, we're going to bring back our alpha command that we used in the density plots, because there might be some overplotting here. Because our feeling thermometer measures aren't perfectly continuous, I think we're going to actually have a lot of overplotting here, so I'm going to use a really low alpha. And remember, alpha works in a 0 to 1 scale, so I'm going to use something like 0.2. When we run this, we'll see that my assumption was correct and that we did have a lot of overplotting. Additionally, the density really does fall above 50 on the FT scientist scale. I think this makes sense as there really aren't a lot of people who are against scientists in general, but it's still interesting to see all these outliers. Using our alpha argument isn't the only way to show density though, and there's actually a way to present that in a 2D format. If we use another geom command, this time geom_rug, and then use a position argument inside of that, and set that equal to jitter, add our plus sign to connect it and then run it, we'll see that we get these bars along the axes that show where the density occurs. This is a bit too noisy for me, but it does its job. We can see that the density occurs above 50 on the FT scientist scale, and it's pretty spread out on the Christian fundamentalist scale. Another fun thing we can do with scatter plots is to look at regression lines. This way, we're able to see how the variables interact with each other directly, and what trends may emerge. In order to do this, we'll open up a new line and use stat smooth. We'll set method equal to lm for now, and we'll set level equal to 0.95 for 95% confidence. Again, we'll add a plus sign to connect it, and then we're ready to run. The regression line we just made is showing a really strong negative trend, where an increase in the FT of scientists is equated with a decrease in the FT of Christian fundamentalists. Additionally, we know that this trend gets stronger as the FT of scientists grows, as our confidence interval is larger here and smaller here. Like always, I'm also going to want to introduce some color and a third variable into the equation, so let's knock both of those out. Like we've done before, we're going to add a third argument into our aesthetics tab, this time being color and not fill, and set that equal to PID3. We're also going to use a manual scale argument, but this time we're going to use scale color manual and not scale fill manual. This is ready to run now, and hopefully we'll see some cool partisan distributions on this plot. While we do get some really nice gradients in here, this is super messy, so let's clean this up a bit. If you remember from my last video, we had a neat way to get rid of these NA values, so let's do that again. To make this change, we'll have to go into our ggplot line, and it'll look like this. What's important here is the exclamation point is.na, as we're telling R to subset our dataset based on the PID3 variable, but without any NA values. Also, while we're here, I'm going to get rid of our geom_rug argument, and I'm going to set the level to false. This is going to get rid of our confidence intervals, but I think it'll look a bit neater. Also, like before, I want to get rid of our little label, so I'm going to set color equal to blank. I think we're ready to run this now. Those changes made this graph a lot easier to read, and a lot clearer as well. The gradient from blue to red is super visible. Additionally, the regression lines are still easy to decipher, and the trends are super clear. Compared to Republicans, Democrats' opinions of Christian fundamentalists decrease drastically as their opinion of scientists grows. While this graph is done, there's still one more way to represent scatter plots that doesn't use a geom argument at all. By using the hex bin package, we'll be able to sort groups of points into bins, similar to how we do for histograms and bar plots. Once you have the hex bin package installed, we can start our ggplot like normal. We'll have our dataset, aesthetics line, and our x and y variables. And in this case, we'll keep the same ones. The change comes in the next line, as instead of using a geom argument, we're going to use stat_bin hex. Running this code will get us something that looks like this. The clear problem here is that the bins are far too spread out. Without any adjustment, the bin measure is usually equal to 30, so we can change that and make them a lot bigger. Inside of our stat bin line, we'll set bins equal to something small, like 5. When we run this, we'll see that the bins condense and they take up a lot more of the plot. I think this is a really cool visual alternative to scatter plots, and we can still see the trends the same. Like before, most of the distribution falls above 50 on the FT scientist scale. The last thing I'll do here before finishing this video off with line graphs is to introduce a new way to color. We can see that naturally we get a pretty cool gradient here, but we can change these colors if we want. In order to get the colors we want, we're going to need to use another scale argument. This time though, we're going to use scale fill gradient. Scale fill gradient needs low and high values, and my low I'm going to set to a dark blue. And for my high, I'm going to set to an orange. I think this should produce something that looks a bit like a heat map, which I think will be a really cool effect. This is pretty visually stunning, and maybe one of my favorite ways to color in all of ggplot. With that being said, I think it's time to wrap this video up and move over to line graphs. Hopefully by now you're a little bit more familiar with subsetting and data framing, so I'll breeze through this code pretty quickly. I started by creating two subsets of the mini ANES dataset based on the non-white variable, where 0 is coded as white and 1 is coded as non-white. These then became my data sources for these two blocks of code. These first 5 lines are looking at white respondents only, and it's finding out the mean feeling thermometer for scientists based on their education level. It's the exact same thing here, except for non-white respondents. After calculating all these means, I created a data frame. Like before, we want everything to line up in columns, so this first column, white 73.121, would be white respondents with a mean score of 73.12 and an education level of 1, which is the lowest. After creating our vectors, we can run our data frame command, and then check our data frame. Everything seems to be in order here, so we can start plotting our line graph now. All of these arguments should look pretty familiar by now, but we'll still run through them. We have our data frame here, our aesthetics tab for our x and y variable, along with color and line type. These perform the same function as something like fill would, where we change the color and the line type based on a variable. In this case, it's race. We have our geom argument below it, then our labels, and then the guides tab, which get rid of our guide titles. Additionally, I have a y-limit argument, so that the y-axis only goes from 50 to 100. Finally, I have two manual scale arguments, one for color and one for line type. This code is ready to run now, and we're left with a pretty nice looking line graph. This can be scaled up in a number of ways, like changing your third variable to something with more categories, or having your x-axis show years or months, so you're able to show something over time. I'm going to leave this graph as is though, and I'll leave it up to you to explore different ways to make this graph more interesting. I hope that I was able to teach you something new in this video, and thanks for watching.